Hello everybody, welcome to my channel. Long time no see. Today I'm gonna share with you guys Leetcode question number 1192, and this is a hard level question, and at least to me, to be honest, it is hard. And when I first saw this question, I didn't know how to solve it, and I think it is hard to you too, because you are searching for a video to watch, and if it is not hard, you will not watch this, right? Yeah, so first let's check the task. In this question, we're supposed to find the so-called critical connection. So in this graph, the result will be this 1, 3 connection. And that means if we remove this one, this graph will be separated into two parts. The first one is this 0, 1, 2, this part, and another one is this 3, the single node. There will be no connections or path to connect these two parts. All right, so yeah, that's the definition of critical connections. So yeah, this is a question about the graph. So it's better to use some graphs to try to understand how to solve this problem. All right, let's use some graphs to show the solution and just translate our thoughts into a programming language. Yeah. So in this graph, there are 8 nodes and 10 connections. Nodes from 0 to 7, and 10 connections is this one, right? 10 connections. So what is the critical connection? Yeah, the definition is not hard to understand. Yeah, the critical connection is that any connection inner circle is not the critical connection, and any circle not inner circle. Any connection not inner circle is the critical connection. That's what we want. So that in this graph, the results will be this one, 0, 4, and 1, 5. These two connections is the result we want, because these two connections, they're not inner circle. All the other connections, this one, this one, this one, this one, and these 3 ones, they are all inner circle. That's not what we want. So yeah, so how can our human naked eyes tell them? Well, the process is that our eyes is just consider all the nodes in the same circle as one single node. Okay, I will say that again. The process of our human naked eyes just consider all the nodes in the same circle as one single node. Just like this one. Our eyes translate this graph into this one, the 3, 0, 2, 1 as one node, just like this, and 4, 7, 6, these 3 nodes as this one, and the connection is gone. So the left connections is this one and this one. These two connections is the final result that we want. Okay, that's the process. That's a process of how our eyes tell the critical connections. Okay, so far we're clear with the process. Yeah, just first go through all the nodes, and then consider some nodes as one single node, and then find the left connections, and that's the result we need. So that's our intuition, and that's the process. Okay, so how can we translate this thought into programming language? Generally speaking, you just get all the nodes using DFS. and we use DFS to go through all the nodes. And if the node has not been visited, let's go deeper. And if we got a node which has been visited, that means we got a circle, because we went back to a node where we have been visited. This means there was a circle that took us back to where we were. So that's a circle. The details will be just like got all the neighbors of one node, and use a variable to check we have visited this node, and go deeper by DFS and consider some nodes as one single node by giving them ID, and the same circle, same ID. The ID will be the minimum value of this circle. If, for example, let's say if the DFS ID order in circle is 1, 2, 3, 4, the final ID of this circle, or we can say the final ID of all the nodes in this same circle, will be 1, because 1 is the minimum value of all the nodes. Yeah, and last, we just get the connections, the left connections. That will be the final answer we want. Okay, let's use this graph. 10 nodes and A nodes and 10 connections. And in this table, each row stands for when we arrive some node in the DFS process. All the nodes ID's value will be in this row. For example, when we arrive at 3 nodes, this node, 3, and when we arrived 3, and from 1 to 7, all the nodes ID will be here. So let's start from 0. Okay, I will give 0. The initial value will be -1, and let's start from 0. I will give 0 node ID 20. Okay, actually you can give any number, 1, 2, 20, 100, 1000, any number. So in this case, let's just give 0 node the ID 20. And 0 node says, okay, I'm 20 and I'm your father, so you're 21. Let's go next. This 1 node. And 1 node says, okay, I'm 21 and I'm your father, so you are 22. And we arrive at 2. And the 2 node says, okay, I'm 22 and I'm your father, so I think you're 23. And the 3 node says, okay, you give me 23, but since I got a 20 from 0, so I think I am 20. And then the 2 node says, okay, so you're 20 and I think I should be 20. And then 1 node will say, okay, you're 20 and I think I'm 20. So far, this circle, the ID of all the nodes of this circle will be 20. So we can consider this one single node. And about this 5, okay, 0, 1, 2, 3, and 5. So actually, when we arrive at 1, at that time, 1 is 21. So 1 said, okay, I'm 21 and think you are 22. My children will be all 22. So the 5 node, he got a 22. And 5 node said, okay, you give me 22 and I have no children, so no children, no change. After my DFS, I'm still 22, so I'm 22. Yeah, so in this row, when we finish the DFS of a 5 node, and the final ID will be 20, 20, 20, and 5 node will be 22. Okay, so after all we finished all the nodes, we go through all the nodes, the final ID will be 20, 20, 20, 21, 22, 21, 21. So this circle, the ID will be 20, and this single node, the ID will be 22, and this circle, the final ID will be 21. So there's 20, 21, and 22. They're different, so we can tell this one and this one will be the result we want. Okay, so I think you guys are clear with the process. Yeah, so after the whole DFS, so let's check the connections to check if they are the critical connections, right? Unfortunately, wrong. Yeah, it's wrong. Okay, let's just check this case. All right, this graph is a little bit different from the previous one because here, uh, just this circle and this circle, the two circles share one node, which is the 7 node here. So the result, the process depends on the DFS orders. So if the DFS order is 4, 7, 8, 9, 6, and all the nodes IDs would be the same, no problems. But if the DFS order is 4, 7, 6, and then 8, 9, that the 6 and the 4 and 6, the IDs are the same, but different from 7, 8, 9. So we cannot check the connections after the whole DFS. Yeah, we should check right after every node finish its DFS. So that's a point that we should know. Yeah. Okay. So let's just check the code. Okay. So we are clear with the process, and so when we check the code, it'll be quite easy to understand, right? So yeah, the parameter is the n, how many nodes are there, and the connections. So let's use a map to store the connections, which means all the nodes that we can go from one node. Yeah, and the IDs, initial values will be -1, and here's a DFS. And in this DFS, it's also easy to know, right? Here will be all the nodes that we can go from one node. And in this loop, there'll be three conditions. The first is if it's parent, we just skip it. And in this one, if it's -1, the ID was -1. That means we had not visited yet. So let's go deeper. And this condition is that if we have already visited, and let's just update the ID. And after this node, the DFS, let's check the connection. All right. Yeah. So let's just check the result. The result will be 1, 5, and 0, 4. Just this one. Right. Yeah. So that's all. That's my solution for this question. And thank you for watching. See you next time.